going through two tasks today, the chi-square test of goodness of fit and the chi-square test of independence. For the chi-square test of goodness of fit, we determine if the height column follows a normal distribution. And for the chi-square test of independence, we determine if there is a relationship between number of youths caught drunk driving and gender. For the chi-square test of goodness of fit, there is 6 steps here that we will go through today. Firstly, we have a data set with 10,000 rows and 3 columns. For our random sampling, we randomly sample 400 rows out of all the rows available. Using the random number generation tool in the data analysis toolpack, we are able to do just that. Afterward, we sort the random column in order to randomly sample our data. Afterward, we go on to data transformation. For this, we split the data into 11 equal parts. Firstly, we define the range, which is the maximum value minus the minimum value. Afterward, we find the range of just one part. How do we do that? We take the range of 11 parts divided by 11, and that gives us the range of each part. Then, we define the lower and upper boundary for each part. And afterward, we combine part 1 and part 2 as part 1's observed frequency was less than 5. Then, we formulate the null and alternative hypothesis. The null hypothesis states that height follows a normal distribution, while the alternative hypothesis states that the height does not follow a normal distribution. Then for our chi-square goodness of fit test, we first have to derive the probability for each part. We use norm dist followed by the upper boundary, mean, standard deviation, and cumulative is set to 1 because we are finding the range of probabilities. Then we derive the expected frequency by multiplying probability by the total frequency. And then we derive the observed frequency by using the COUNTIF function. The COUNTIF function allows us to find all the values within the upper boundary and the lower boundary. So this will give us the observed frequency for one part. Then for our chi-square value, we apply this chi-square formula of observed frequency minus expected frequency, the whole thing squared, divided by the expected frequency. This allows us to get our test statistic, which is 10.779 in our case. Under our degrees of freedom, we get 10 minus 1 equals to 9. And for our chi-square critical value, we use the chi-square inverse formula, and we use 0.95 because of our 5% significance level and 9 because of our degrees of freedom. Doing that allows us to get 16.919, which is our critical value. Since our test statistics is less than the critical value, we fail to reject the null hypothesis. Thus, we conclude that height follows a normal distribution. Now we go on to the next task, which is the chi-square test of independence. Here we have 5 steps that we have to take. Our dataset this time has 735 rows and 3 columns. We also apply random sampling to our 735 random numbers. Afterward, we sort the random column and we sort the data in ascending order of the random column. This is similar to what we have done just now. Then, we create a pivot table of the observed frequencies. We select the first 619 columns and create the pivot table here. So we can see our row labels. This is for the number of youths who did not drunk drive. Then yes is for the number of youths who were caught drunk driving. And this is their gender. We formulate the null and alternative hypothesis, where the null hypothesis states that the number of youths caught drunk driving is independent of gender. And the alternative hypothesis says that the number of youths caught drunk driving is not independent of gender. This is our observed frequency table, and this is our expected frequencies table. So how is our expected frequency calculated? Each value is applied to this formula of value equals to the column total, which is the column total here, and multiplied by row total, which is this way, and divided by grand total over here, which is our total here. The chi-square table, each chi-square value is applied to the same formula of observed frequency minus expected frequency, whole thing squared, divided by our expected frequency. For this particular distribution, we find out that our chi-square test statistic is 5.12. So using our chi-square test of independence, we find that there's 619 observations, 2 rows, and 2 columns. Our test statistics is 5.12, and our degrees of freedom is number of rows minus 1 times number of columns minus 1, which gives us 1 degree of freedom. As such, our chi-square critical value at alpha equals to 0.05 with a degree of freedom of 1 is 3.84. Our results show that the test statistics of 5.12 is greater than our critical value of 3.84. Thus, the evidence is strong enough for us to reject the null hypothesis at a 5% significance level. As such, drunk driving is not independent of gender. In other words, the number of youths caught drunk driving does differ by their gender. Thank you so much for watching my presentation and have a great day ahead.